we'd like to show how to integrate CKFluid Chem Kinetics into a C or C++ based program. So once the user clicks on the compiled compute chem, which means after all the data are being supplied, there are a number of files that are produced that can help to connect the CKFluid data with a C or C++ program. So the list of files that are produced are listed within the working directory. So in this case, we have a 32-bit DLL, which is produced under Windows XP 32-bit. So to connect and use a C or C++ program, we need the DLL and the chemsource.c. And the chemtest.c is just used to demonstrate how to use it. So basically what one needs is to compile the chemsource.c with the actual C or C++ program. In this case, we use this example of chemtest.c, which represents any user-defined C program that uses the Chem Kinetics DLL. So there are two types that could be produced. So the user just has to have those files available within the working directory. So I'm just going to use a simple compiler and show how to do that. In this example, we just show how to do it in the compact visual Fortran. It could be digital Fortran from Intel or any other C or C++ compiler. They will work very well. So these are the two files that are needed to run the test. So what is done, we just apply them and then compile. That's it. So in this case, when we compile, the file is then created. So everything is created down there. Then we will just run here the executable, and then the result will be done. So for this case of this working environment, we still have to specify the input folder. So we supply it as the input folder here, or we can use it in the command line. So when we run it from here, the DLL will be then executed. So the DLL is executed, the data are being produced. So let me make it sure that the user sees it. So this is the result from the execution. So these are the results being produced from the DLL that we just ran. So all of it is here, and it's very clear that these data are basically similar to the one that one would use in getting from MATLAB or other programs. So we see here, it shows us the number of chemistries that we have there. We have two. One of them is empty, so it has no data, and then the two others are contains data within them. So the two reactions that have rates of non-zero values are displayed, and then the other ones we just set the rate constant as being 0, so for the sake of the demo. The reactions rate are irreversible, so reverse rate is 0. The forward rate are computed. The enthalpy of reactions are computed, and the source term for the heat is then displayed as well as the source terms for mass. The input concentrations are displayed, and the corresponding species are displayed. So we had 9 species in this case. So that's as simple as it can be. It's very easy and very much user-friendly to then use within a C or C++ environment. So this is the complete data set that we get from this run. So we could also run the same example from the command line and then supplying the actual input directory that contains the DLL and then execute it. So once we compile the file that we just showed here from this compiler environment, we could run it from the command line by supplying the data. So by supplying that, we click on enter. So the program is executed again. So we have all the values supplied, including the rates, and then the stoichiometry, and then the species and the source terms are then just displayed correctly. So that's an easy way to do. So the program that we have, which is the chem test itself, is just used to give the user an idea of how to hook it up. So when we look at that, so there is the main program. This is the main program, and then the main program, which is the main, which then invokes, it sets up the chemistry, so it prepares it, and then after that there is the main loop, which is here. So this is the loop, the actual loop for this, which is the loop here. So the loop then will just supply the data and call here. So the actual concentrations are made into a struct. So we made a struct that will contain the information for all the chemistries. So there is a struct that contains concentrations, source mass, heat, and rate, and as well the index that correspond to the chemistry, and then the time, which is possibly not used there but is still required, the pressure, the temperature, and the total concentration. So this is the actual chemistry. So once we have prepared it, we just loop over the number of the chemistry that contains. The display is just a routine that has made here to show us how to access the different values that are obtained from the chemistry. So the struct that we made is just a struct, which is a list of all the pointers and the values that are being obtained from the chemistry. This is a struct from C, which is a very easy one to use, and then to hook up with the chemistry module. So that is it as far as the chemistry is concerned from the main program. So this is the main loop from which we call the chemistry. So there are two ways of calling it. The first one, which we commented out. The second one, which will then allow us to compute the rate as well, or to obtain the values from the rate as well. The first one, the chem source, doesn't obtain the value from the rate. It just get the value from the source terms. So sometimes it would be better to get the values from the rates as well. So there is a prepare routine, which is the prepare routine, which is here, prepare chemistry, which is then just used to prepare all the pointers and all the arrays which are being used inside the chemistry routine. So that's it. It's very easy and very user-friendly. Thank you. Thank you. That's what it takes to hook it up with a C and C++ program.